Let us continue Introduction to Circuit Analysis. The only one thing that we are going to continue today is AC analysis, because in this particular subject there are two important precautions a student should take. You have to deal with dependent sources in every topic, and you should also deal AC analysis in every topic, unlike BTEC. Normally in your graduation, what people do is they'll teach or they'll learn AC analysis as a separate part. It's almost the last part of network circuits or electrical circuits. But in competitive exams, you can't have a unit-wise system. You'll be having all units put together. For example, AC analysis will start right from the first topic itself. So, the very important precaution is you need to refer books which is dealing with AC analysis in every topic. For example, when you are talking about Kirchhoff's laws, you should talk about AC analysis. So, let us talk about the introduction so that we can use the problems AC and DC, dependent sources all together. Then only you can really do competitive exam particularly. So AC analysis, we only say you can represent as this way. This is a source. DC is independent of time, but AC depends on time. And then impedance R plus Jx. So where V of t can be sinusoidal or cosine. Actually, when you say sine and cosine, both put together we call sinusoidal. But the way we represent is this: V naught cos omega naught t plus theta naught. I am very careful here. So some people, they are simply saying V cos omega t plus theta. That is not correct. In this expression, if you see, you can say suffix is there. So wherever there is suffix, that means they are fixed. And that's why there is only one variable t here. So that is a very important precaution. Whether books are following or somebody is following or not, you have to follow this carefully. In actually speaking, when you say O is generally called operating conditions. That means V naught is operating voltage, omega naught is the operating frequency, theta naught is the operating phase angle. Therefore, in the entire expression, only one thing is changing, that's called t. By mistake, if you remove omega naught and simply say omega, that becomes a random variable. So, let us not give any such impression. It's only varying in terms of time, all others are fixed. And the same thing can be put in the form of V naught angle theta naught. So when you say angle theta naught, we are ignoring the frequency. One important precaution you must understand, in electrical circuits or networks, as we already discussed, RLC components are linear. When RLC components are linear, the frequency will never change in linear circuits. When the frequency is not changing, we can simply assume and ignore that frequency and simply mention only the amplitude and phase angle. Please remember, we are only going to calculate two things: how much amplitude is coming and what is the phase angle created. Because the circuits are passive circuits, most of the time amplitude will be less than the input and phase angle will be more than the input. So phase angle wise, some phase will be created, amplitude, it will be attenuated. So we need to check only two things. We need to check the amplitude, we need to check the phase angle. We don't need to check frequency, because frequency is fixed in a linear circuit. That's a very important assumption or understanding in electrical circuits. Let's see, for example, this is the circuit we have. This is V of t, resistor, inductor and capacitor. For this one, if you apply Ohm's law here, Faraday's law here and Faraday's law of electrostatic here, if you apply, all these things as we discussed in the last class. You can say V of t minus IR L di by dt minus 1 over C integral I dt is equal to 0. This is called time domain expression. If you apply Fourier transform, don't be shocked. Fourier transform is basically simply say, if it is differentiation, it is multiplied with j omega. If it is integration, divided by j omega. Therefore, V of t will become V of omega, I of t will become I of omega, differentiation become j omega, integration become 1 by j omega. Therefore, if you really write this expression, V of omega I of omega into R, j omega L I of omega minus 1 by j omega C into I of omega is equal to 0. There is a very important understanding required. For example, look at this R. R is basically ohms, L is Henrys, C is farads. But if you apply Fourier transform, R simply, if you convert a time domain function into frequency domain function, you know what's happening? R is ohms, j omega L is also ohms, 1 by j omega C also ohms. Please understand, by converting the differentials and integrals, we are converting all the three components into ohms. That's a very, very serious observation. Therefore, R becomes R, L becomes j omega L and SL, C becomes 1 by j omega C and 1 by SC. So, first line is for Fourier transform, second line is for Laplace transform, and that is how the components are converted. So, this is very important thing to observe in AC analysis. Then, if you see how to analyze, because computation is important. When you are really calculating things, you have two things. One is called rectangle form and polar form. Rectangle means xy, polar means amplitude and angle. So, in AC circuits, we are studying voltages, currents, impedance, powers, all are in the complex form. These quantities represented in either rectangle form or polar form. Please observe here, if Z1 is x plus j, that is converted into r angle theta, where r is equal to root of x square plus y square. Theta is equal to tan inverse of y by x. So, this is how we convert a rectangle value into polar. Let us see the other thing. What are the properties here? Suppose you have Z1, x1 plus jy1, Z2, this is r2, angle theta 2, x2 plus j2. When you are adding and subtracting, we go for rectangular. When we are multiplying and dividing, we go for polar. Please observe here. When you are adding, the real parts called added, imaginary parts are added, and subtracting, real parts subtracted and imaginary parts subtracted. When multiplying, the amplitudes are multiplied, angles are added. When you divide, amplitudes are divided, angles are subtracted. This way, you can convert rectangle into polar and polar into rectangle. But one important observation for student, these conversions we don't need to do analytically. We don't need to do on the paper, because in the calculator itself you have direct conversions. If you observe the calculator P to R and R to P, that is actually doing this job. So, that you can always use, because such a calculators are allowed in every competitive exam, and rectangle to polar you don't need to do like this and waste your time. You can directly convert from the calculator. Let us go to problems. The first problem is two incandescent lights bulbs of 40 watts and 60 watts are connected in series across the main, and then option A, the bulbs together consume 100 watts, the bulbs together consume 50 watts, then the 60 watt bulb will glow brighter, the 40 watt bulb glows brighter. The answer is very simple. The answer is, when you look at the solution, when you look at two things connected in series, suppose you have a 60 watt bulb and 40 watt bulb. 60 watt bulb takes more current. 40 watt bulb takes less current. Less current can go in the higher one, but higher current cannot go in the lower one. Therefore, the effective current in this total loop is 40 watts. When you send, because when you talk about series, please understand, and when I talk about series connection I am introducing, suppose you have a big pipe, water pipe I am talking, a small pipe. How much water will go? The small pipe water only will go, because when the big pipe water is coming, small pipe cannot accept. So small pipe water will go in the big pipe water will not go in the small pipe. So the net amount of the water circulated in the two different pipes is small one. Similarly, in series connection, when you have two current ratings, the least current flows. When the least current flows, the least current is basically 40. So when 40 is growing, it will give more brighter, because 60 cannot give. Because 60 watts bulb is expecting more current, or required current is not supplied. So required current is supplied only for 40 watts. Therefore, 40 watt bulb will be brighter, whereas 60 is only supplied 40. That's why it cannot be brighter. This is what we are thinking about this problem. Second problem. That's why, therefore, the answer is D. Answer is D, means 40 watts will grow brighter. Let's go to the second. The energy absorbed by the inductor having 1 ohm resistance with 2 Henry's inductance is what? The energy absorbed by the inductor having 1 ohm resistor with 2 ohm inductance, this is what current is given. This is given in the problem. When this current is given, what is the energy? These are the options. Now let us see. The whole working out is very simple. Two simple principles I am going to take. The power, the energy is equal to power into time. Look at here. Energy dissipated by resistance. I RMS square into resistance into T. Why do you need T? Because I square R gives only power. But when you want to convert power into energy, you must multiply with time. That's why I have used this expression. Now, but if you see this waveform, the waveform has two splits. 0 to 2 seconds it is ramp. 2 to 4 it is a constant. So when you go for 0 to 2 and 2 to 4, how much is dissipated? Let us see there. I have calculated separately. 0 to 2, 6 by root 3 whole square into 1 into 2 minus 0. What is this 1? As you see here, resistor is 1. Then what is this? 6 by root 3 square is here. Why 6 by root 3? Please remember, there is a very important thing one student should understand. For sinusoidal signal, it is maximum by root 2. But whereas for triangle, it is 6 by root 3. So this being a triangle or a ramp signal, we take 6 by root 3 whole square into 1 and 2 minus 0, because time, how much time it is there. Because we have to multiply with time in order to convert power into energy. Therefore, this is 36 by 3 becomes 12. 12 into 2 becomes 24. So for that 0 to 2, the total energy is 24 joules. I hope you know energy is always measured in joules. Now let us take the second part. Second part is from 2 to 4. As you observe, it is a constant value. So we don't need to say by root 2 or anything. You can directly say 6 square into resistance value R. I am following this equation. And 4 minus 2, because it is spreading from 2 to 4. So therefore, 36 into 2, 72 joules. this much is the energy dissipated by resistor. Then I need to go for inductor. For an inductor, energy stored by inductor is half Li square. That's a standard formula. And 0 to 2, that is half, L is 2 Henries, current is 6 square. Therefore, this is 36 joules. Then 2 to 4, look at the 2 to 4. 2 to 4, the value is constant. If the value is constant, half into 2 into differentiation of a constant is always 0. If a differentiation is 0, the total value becomes 0. That's why please remember, whenever you give DC current to an inductor, it becomes 0. That because we are differentiating it. So therefore, total you please add it up, 24 plus 72 plus 36 plus 0, total becomes 132. And if you see the options 132, answer is B. So for this problem, though it is little bit difficult, whenever a problem comes like this, normally 2 marks are given. That's why don't worry, this is 132 joules is the answer. Answer for the second question is B. Then let's go for, this is the answer as mentioned, B. Then let's go for third question. Which of the following gives ideal voltage source VI characteristics? As I discussed in the theory in the previous lecture, when you say ideal voltage source, we have internal resistance 0. When internal resistance is 0, whatever you give will come. So let the current change, let the voltage change, but this value is constant or fixed. Therefore, option is, this is the option. Answer is A. So answer is A, and which is given among all the 4 options. Because when you say ideal voltage source, it is so ideal, whatever the value that you are giving, that will come. Let the load vary, nothing will change. This is our, let's go to the next question. A 10 volts battery, as you look at this diagram, a 10 volts battery with an internal resistance of 1 ohm is connected across a nonlinear load. This is nonlinear load, for example, whose VI characteristics is given by 7I is equal to V square plus 2. You know, when you look at this expression, you can clearly see this is nonlinear. What is a nonlinear? 2V is a linear and V square is nonlinear. Therefore, because you have connected some nonlinear load, the VI equation is not simply like Ohm's law, it is plus something else, that is square term. Nonlinearity is mentioned by this. The current delivered by the source, he is asking how much current is delivered by the source. See, therefore, let us see the expression and let us substitute that expression there and solve for the current. Definitely this being a nonlinear, you will get more than one value. Whenever you have a quadratic equation, you will definitely have more than one value. So I am going to show you in the solution what are the different values and finally how we choose it. So I'll be back to the options after solving it. Look at here. If you look at this, you can see 10 volts, 1 ohm into I, and this is here. So if you apply, for example, 10 volts minus 1I minus V is equal to 0. I am repeating, 10 volts minus 1 into I minus V is equal to 0. So that is what it is. Therefore, I into 1 plus V is equal to 10. This is the relation between V and I. And take this relation, substitute here. Sir, please observe what I am doing. In the place of, I am substituting this equation in this one. And when I substitute this equation in this equation, I will be getting I minus 5, I minus 24. That means what? I is equal to 5, current can be 5 amperes, current can also be 24 amperes. Because as I already told you, you have what we call basically this talking about quadratic equation. In this quadratic equation, two values will come, but you now please come back to the options with your 5 and 24 and pick out the option, and 24 is not there. That's why I am choosing answer is D. This is the answer that we have. So it's very interesting. Two answers are there, but you need to take the best answer. Please understand, in objective question papers generally when there is a two answers, you need to take the best answer. That's what we did. Now I am taking another question to illustrate the basics. We have not yet gone to KVL or KCL. We are simply on the components. We need to understand the basic idea of these problems is just to understand RLC and their VI relationships. Look at here. The voltage and current waveforms for an element are given. The circuit element and its value. You need to understand what is the element, and you also should understand what is the value. So look at this current, look at this voltage. So what is the relation between these two waveforms? Very simply, this is a constant, just like y is equal to mx. I can say I is equal to 2t or something. So when you have a straight line and when you differentiate it, you will get constant. Please remember, differentiation of this wave becomes 0 and differentiation of this become a constant. For example, I'll tell you differentiation of t is 1. That's why differentiation of a ramp is a step, differentiation of a step is 0. So he is very clearly giving an idea the relation between V and I. Indirectly it is differentiated. What is differentiated? You have three equations. V is equal to Ri, V is equal to L dI by dt, V is equal to 1 over C integral I dt. Among these three components, definitely it is L. That's why observe here, differentiation of a ramp, you can take it, so says integration of a ramp is step, that means derivative of a step is that reverse. From the current and voltage characteristics, if I of t is t, V of t is 2t then. I mean, we are integrating it. When you differentiate, it will become a constant. Therefore, you can clearly say one word, this is basically an inductor. If it is an inductor, what is the relationship? V is equal to L di by dt. What is V? He said, if you see this curve, he said it is 2 volts. So V is 2 volts. And how do you get this 2 volts there? L di by dt. So L is as it is because we need to calculate it. What is di by dt? That is slope. And you can calculate the slope from this curve. Please calculate the slope from this curve. This is 0, 0, 2, 2, 2 minus 0 minus 2 minus 0. The total slope is, if you can see here, in ordinary mathematics, if 2 and 2 coming, slope is 1. Therefore, I am keeping slope as 1. So 2 is equal to L di by dt, that is 1. Therefore, automatically inductance value is 2. So we have identified the component as inductor and we have also identified the value as 2. And now let us go back to options once again to see there. What is the option? Is it a resistor? No. Inductor. Luckily, there is only one inductor. Actually, without calculating, you can easily say, because suppose if another option is having inductor, then you need to really calculate the value. That advantage you always enjoy. There are two advantages in multiple choice questions. When there are two things to be calculated, by calculating one, you will get the answer like this. By mistake, if the examiner gives here also inductor, you are in trouble. Otherwise, the moment you identify the answer, you don't need to check because 2 is already there. So that is one way you need to enjoy. In matching also the same thing happens. In matching 4 things, if you know at least 2 correctly, automatically you can manage. So enjoy this facility in multiple choice. He said only inductor, then you are very clear. Answer is also cross-checked as 2. So that therefore the answer is B. So let us check it. Once again, their answer is B. Let's go to the next problem. When a resistor R is connected to a current source, it consumes a power of 18 watts. If a current source is replaced by a voltage source having the same magnitude, the resistor consumes the power 4.5 watts. What is the magnitude of current source and the resistor? So look at this when it is asked, and how many marks I have mentioned there, because I want to encourage you to see it is given for 2 marks. 2 marks is not an ordinary thing in the GATE exam. Now, the very first you should understand the question. Before I go to solution, I am least bothered about the options. I am also least bothered about solution, but I am more bothered about understanding the question. Please look at the question. He says there is a resistor. There is a current source. Current source, resistor, they are in parallel. They are giving 18 watts. And if you convert into voltage source, resistor is in series, and then the power is 4.5 watts. But the very important condition he gave in this question is the value of the voltage source and the value of current source is same. That's a very important precaution. So let us calculate 2 things here you need to calculate: the magnitude of current source and the value of resistor. Now please come with me to the solution. I have made this concept very simple. Look at here. There are 2 powers involved. One power is I square R, that is 18 watts. Second power is V square by R, 4.5 watts. Why? Because when you would say power in current, I square R, when you want the power in voltage, it is V square by R. Please take these 2 values. And what is the equation he said? He said voltage is equal to current. When voltage is equal to current, you substitute V square means I square. Why? Because he is asking for current. So I will convert the voltage into current. For example, look at here. Then this is 4 I square R, 18 watts. This is also I square R, 4.5. If you really divide I square R, I square by R, I square will cancel. You will get R square. Therefore, R square will become, you will get 18 by 4.5. And if you substitute, you will get the value of R. Because R square is equal to 18 by 4.5. And if you really see this 4.5, 18 by 4.5, it is 4. Therefore, R square is equal to 4. Therefore, R is 2 ohms. And what about current? Current is very simple now. You just come here. You understood R is equal to 2. If R is equal to 2, I square R is 18. Then what is the answer? I square is 18 by R. That means 18 by 2 is 9. If I square is 9, I is 3. So therefore, the value of current source is 3 amperes. The value of resistor is 2 ohms. Shall we go back to with these 2 answers, shall we go back to our options? So this is 3 and 2. Therefore, option is B. So this is how you need to simply understand and how options are given. The any link that is given in the question, be careful. So let's go for next problem. An ideal voltage source will charge the ideal capacitor. How does it charge? Suppose you give a voltage. It give a voltage source to a capacitor suddenly. So how much time does it take to charge? Will it take infinite time? Will it take instantaneously? Exponential increase? None of the above. Look at here. We know that I is equal to CdV by dt. He said he said this value is ideal without any resistor. How much time it will take? Capacitor will charge us instantaneously. Actually, this happened once in the lab. One student has gone to check how the capacitor is working. He has directly taken the capacitor and put to the 2 points of the supply. And you know what happened? When you don't put any resistor, you are not allowing the capacitor to charge. When you are not allowing the capacitor to charge, the total voltage whatever you give should appear across the capacitor parallelly. That's why we say whatever you have given will be seen across the capacitor parallelly. That's why instantaneously will come. But you know what happened in the lab? When the voltage, when somebody has given, that was the first year of the college that we started, and that was the first lab students are doing. They want to really enjoy the lab and understand what's happening. He has connected capacitor directly to what you call battery. Thank God he is not touching it. Had he was touching it, he would die on spot. There was a big bomb sound came. It's all because you are not allowing the capacitor to charge its own way. You are asking the capacitor to charge instantaneously. By mistake, if the voltage, the battery is giving more voltage beyond the capacitor capacitance and rating, it will be burst. That is how actually bombs work. And this is what it is basically speaking. It takes instantaneous time for the total voltage be seen there. And see, whenever you talk about resistor, there are 2 ratings. Suppose you go to any shop and ask for a resistance of 1 kilo ohm, they'll say what is other specifications. Every component has 2 specifications, please. Because we are talking about, I am introducing RLC components and now I am talking about capacitor. Let me talk about all the 3 at a stretch. Resistor is ohms along with wattage. If the wattage increases, the size of the resistor increases. And sometimes if the wattage is very high, it is becoming as big as a rheostat. So resistor is ohms along with wattage. Inductor is Henrys along with the current rating. Capacitor is voltage, capacitance like farads along with voltage. So every capacitor has what you call voltage rating. If you suddenly directly connect a voltage source without internal resistance, you know why this was called actually ideal voltage source? If you say practical voltage source, what happens is source will have internal resistance. That internal resistance will have a path for charging. That's why the examiner is very serious. He said very clear, ideal voltage source. That means there is no resistance coming from the source or no resistance you are connected. Neither you are connecting the resistance nor source is having it. Therefore, absolutely there is no resistor, only voltage is put upon it. Therefore, it is instantaneously charged. Therefore, they look at the solution, the answer is B. It is instantaneous. That's a very interesting answer. You just check your basics strong. Now, practical current source will be represented as, if you really go back to my basics concept that I have dealt in the previous lecture, current source means source in parallel with resistance. Voltage source means voltage source in series with resistance. Therefore, look at here. A series resistance with the ideal current source? No, current source will never have series resistance. Current source should have parallel resistance with ideal current. A resistance in parallel with ideal voltage? No, because he is talking about current source. Please rule out the last 2 options. That's how you need to check your multiple choices carefully. Most of the time, they will help you. For example, he is talking about current source and C and D talking about voltage source. Eliminate them first. 50% answers have gone. You are only left with, this is like a 50-50 chance. And when you see 50-50 chance here, because the voltage sources are eliminated, you are only talking about current source. Current source should have a parallel resistance. Why? If current source is not having a parallel resistance, the loop is not continued. If loop is not closed, current source has no meaning. Therefore, as I discussed in the theory class, the concepts there, I am also concluding ideal current source in a parallel resistance. Therefore, option is B. See, this is the option. A resistance in parallel with it. All this I have told you because you need to have an adjustment of how to eliminate the unnecessary answers. So once you know elimination, you will be very strong in your understanding and you will be very good in answering your questions. Let's go to the ninth one. Ninth question is, energy stored by a capacitor over a cycle when excited with AC source. So look at the energy stored of a capacitor. Energy is always half CV square if it is really known, otherwise integration. So energy stored by a capacitor over a cycle when excited with AC source, same as DC, half of the amount of DC, 0, none of the above. These are the options we have. Please remember, this question is carrying only 1 mark. You know why? There are 2 types of questions in the exam. Concept based questions are generally 1 mark. Calculation based questions are 2 marks. So observe as the lecture goes. And then the options are this. When you have a constant, because when he says, look at again, excited with AC source over a complete cycle, when you have instantaneous power, power is generally called voltage and current. So when you integrate power, you will get energy. You know why? Because power into T is energy. This integration is actually talking about into T to add the time value there. So if you add the time value there, it is 2 omega because you are taking 0 to pi, and it will, after integration, sign will become cos, and cos 2 pi is 0, or cos 2 pi is 1, minus cos 0 is 1, therefore 1 minus 1 is 0. The answer is 0, that is option C. So look at your once again the options that we have. This is 0 because the whole idea is over a cycle. That is what it matters. If it is not over cycle, it will be something else. So that's our question, and let's go to the next question. For which type of a voltage source the nature of current through the inductor is DC? For which type of a current source the nature of inductor, for example, the nature of current through the inductor, please remember that. What kind of voltage should I give so that I is DC? What is I? I is equal to 1 over L. Current through an inductor is 1 by L integral V dt. Now, this should be constant, means this should be impulse. Therefore, integration of an impulse is DC. That's why voltage should be impulse in order to give DC here. So option is C. So this is the question that we wanted to study. Let's go to next. A metal resistor having 10 ohms and 11 ohms, this 160. What is the temperature coefficient of the resistor? See, one thing you must understand, resistor always depends on temperature. That's why when you are talking about Ohm's law, we say at a fixed temperature. But now we are relaxing that condition. At a fixed temperature is not the point. Now temperature is changing. We need to calculate what is the temperature coefficient. I'll take you for the example or the equation. R2 is equal to R1 into 1 plus alpha T2 minus T1. That means he said R2 is 10, R1 is 11, 1 plus alpha 160 minus 0. If you solve for alpha, this becomes 0.000625 per degrees centigrade. If you see the options, you get here the option is D. So option is D. So very simple, it's just like a plus 2 intermediate things, and we talk about this value. Let's go to the next. When n resistors are connected in parallel, equivalent resistance is X. While connected in series, how much? This is very interesting here. When n resistors are connected in parallel, the equivalent resistance is X. While connected in series, how much? Let's see the value there. When n resistors are connected in parallel, equivalent resistance they want for X is X by N. If it is series, Nx. So there are two options here. When they are connected in parallel, X by N. While they are connected in series, it will be multiplied. So with this logic, you need to solve this problem. So always remember, parallel means X by N. Serial means N into X. Looking at that value, you need to solve this. Let's go for the resistance of a wire is 2 ohms. If the diameter is reduced to its half and keeping the length as constant, the resistance is, once again, the resistance of a wire is 2 ohms. If the diameter is reduced to its half, keeping the length as constant, what will happen to the resistance? Will it be same or double or triple or 4 times? That is what we need to think. Let's go for the equations involved. As you all know, R is equal to rho L by A. Now, R2 is rho L by A2 because he said L is constant. Automatically, the resistivity is anyway constant. So, rho L by A. Then, that is A2. When you say R1, rho L by A1. And if you take this ratio, you will have A1 by A2. When you have A1 by A2 here, take the ratio. What is A1? Area 1. That is pi r square 1. Pi r2 square. This is the area. Now you convert these areas in terms of radius into in terms of diameter. That's also same. But what he told in the exam question paper is d1 square by 4. Why d1 square by 4? It's only, if you look at the question, he said only half. But half square is 4. That's why I have taken this 4. And these two will cancel. You will have 4. So R2 by R1 is 4. Therefore, R2 is 4 into R1. R1 is 2. 2 into 2 is, 4 into 2 is 8. Therefore, option is D. So the value you have to do in this way. This problem is actually to tell you, please look at these options. The answer is 8. That's why I said D is option. This problem is basically to tell you how the physical dimensions of the component will affect the resistance. So in the concepts, in the lecture I have given the concepts, previous lecture, where I have clearly given for all the 3 components what are the physical equations. R is rho L by A, C is equal to epsilon D by A. Like that I have given the values. So here it is all together to tell you, if you want to bring any change in the value of the resistance, you can change it by looking at, by changing area or the diameter. So this is the answer for this. Let's go to the next. For an electrical appliances, that means there are so many electrical appliances. Okay. The rating is decided by considering what? We say the rating. For example, you talk about transformer. When you say transformer, the best example, you don't call about current or voltage, we call about power. And that's why most of the things, when the transformer rating is mentioned, it is VI. And power rating is mentioned. That's why kVA, it is mentioned in most of the transformers. When you go and see, the transformer ratings will mention kVA, kilo, volt, ampere. That means the power. So we will have this power as an option. Actually, sometimes you can take current, but the best option would be the power and this.